In this section, we're going to be doing double angle identities, and then eventually we'll do half angle identities. Now, what does double angle identities do for us? Okay, if you know the sine of 30, then you can use a double angle identity to find the sine of 60, which we already know, but you get kind of the right idea. You can use the double angle identity if you know the sine of 45 to find the sine of 90, and so on and so forth. Now, here are your double angle identities. The sine of twice an angle. If you know the angle, the sine of twice the angle would be 2 times the sine of the original angle times the cosine of the original angle. Then you see there's 3 different double angle identities for cosine, and there's 1 for tangent as well. So let's go ahead and jump into the problems. It says, first off, let's find the sine of 2 theta. Well, how do you find the sine of 2 theta? You use this identity. If you know the original angle, then you can find the sine of double the angle. But look, there's an issue here. They tell us what the cosine is. We don't know the original angle. Now, if we knew that theta was 30, no problem. We do the sine of 2 times 30. But here's how we're going to find this. To find the sine of 2 theta, let's write down the identity. It's going to equal 2 times the sine of theta times the cosine of theta. That's how we're going to find it, is by using that identity. And we're actually going to be able to find it without even knowing the angle at all. We know the cosine of theta is 8/17. Now we could find the angle. We could do the inverse cosine. We know that the angle is somewhere between 270 and 360. We could find that angle. However, let's work this problem to give us a little bit of extra practice without ever knowing the angle. So let's zoom in. So I'm looking for the sine of 2 theta. I'm going to find it by doing 2 times the sine of the original angle times the cosine of the original angle. Now, cosine of the original angle, look, it's right here. The cosine of my original angle is 8/17. Now, this part tells me, again, my angle is between 270 and 360. Now, what does that mean? My angle is in the 4th quadrant. That's all you need to know. My angle's in the 4th quadrant. Why do I need to know that? That tells you all students take calculus. That tells me that the only thing positive in that 4th quadrant is going to be cosine. So therefore, how am I going to use this formula? I've got my cosine. I need to find out what would sine of my original angle. My original angle, again, is somewhere in this 4th quadrant, somewhere down here. Cosine's the only thing positive. So what you're going to do is I'm going to draw me a triangle. And you can do this one of 2 different ways. This is the first method we did it. My original angle, theta, is in the 4th quadrant. I know that the cosine is 8/17, which is adjacent over hypotenuse. If you were to use Pythagorean triples, you know that 8, 15, and 17 is a triple. So therefore, that tells me that the sine of theta, my original angle, not the double one, the sine of the original angle would be opposite over hypotenuse. Now, why did we draw this whole thing? Because we're in the 4th quadrant, so therefore sine would be negative. So what I now have, I have an original angle that was somewhere in the 4th quadrant, somewhere between 270 and 360. Now, what I'm going to do is I'm going to double that angle. So that makes it somewhere between like 540 and 720. I'm going to double the angle, and I'm going to find the sine of it. Now, how do I do it? I do 2 times the sine of the original angle, which I just found, times the cosine of the original angle, which was given to me. Now, what's cool about this formula, it actually works out the positives and negatives for you. You don't have to worry about them anymore. So I'm going to do multiply positive, negative, negative. It's going to be or positive, negative, positive will give you a negative. Multiply all the tops, gives you 240. Multiply all the bottoms, and it gives you 289. So therefore, the sine of my double angle would be negative 240 over negative, or positive 289. So therefore, what quadrant would it be in? You can think of it. My first angle is between 270 and 360. If you double that, again, that gives you somewhere between 540 and 720, which is somewhere in either this 2nd or 3rd or 4th quadrant. Since it's negative and I found the sine of it, well, it could still be in either one. Okay, but that's how you work these. Okay, the tan, find the tan of 2 theta. First thing we do is we're going to write down our formula. Go back to the top. The tan of 2 theta is here. Let's write that down. So the tangent of my double angle will be 2 times the tangent of my original angle, over 1 minus the tan squared of my original angle. And all they give you is sine. And they say that you're in this quadrant between 180 and 270. That would be quadrant 3. So let's figure out what, to plug into our formula, we need a tangent of our original angle. So if sine is equal to negative 1/3, all students take calculus, tangent's going to be positive. Let's draw that triangle. If the tangent is equal to 1/3, or excuse me, sine is equal to 1/3, that'd be opposite over hypotenuse. Pythagorean theorem is going to give you that this is equal to √8. So therefore, the tangent of my original angle will be opposite over adjacent, which is 1 over √8. And you can rationalize that if you would like. That's going to be √8 over 8. And we can simplify that a little bit. That's going to be √4 times √2, which will be 2√2 over 8, which is going to be √2 over 4. Now, that's the tangent of my original. So now, how am I going to find 2 times tan theta? Which, by the way, that was positive because we were in quadrant 3. How are we going to find the tangent of the double angle? You're going to do 2 times the tangent of your original angle over 1 minus the tangent of my original angle squared. Okay, we got to square this. So square the top and square the bottom. 2 over 16, let's reduce that. That's 1/8. So now just clean it up and you're done. Cross cancel. Leaves you with on top a √2 over 2. On bottom, 1 minus 1/8, which is 7/8. Let's flip and multiply. That's going to be √2 over 2 times 8 over 7. Cross cancel leaves you with a 4 and a 1. So that gives you a 4 √2 over 7. That's the tangent of the double angle. Okay, the next one, number 3. Says if the tangent is equal to negative √7 over 5 and you're between 90 and 180, which that's going to be quadrant 2, find the cosine of 2 theta. Well, first off, we need to find the, again, identity for the cosine of 2 theta. And we can either use these up here or we can use our identity sheet. Cosine of 2 theta is located right here. It's any of these 3 in the middle there. Let me go to those. Now notice that all depending on which one you use, this one involves cosines and sines. This one involves just sines. This one involves just cosines. So we're given a tangent. So we're going to have to use tangent to find either cosine or sine or both, and then pick accordingly. So it really doesn't matter. We'll just use this middle one, 1 minus 2 sine squared. So since we're in the second quadrant, all students take calculus. So let me draw me an angle. We're here. All students take calculus. That means sine is going to be positive. So now let's draw me a triangle, and let's try to find out what sine would be. Here's my theta. If tangent is √7 over 5, again, we don't have to worry about the positives and negatives because this will take care of that. Tangent would be opposite over adjacent. Pythagorean theorem tells you that then the hypotenuse would be, let's see, that'd be 25 and 7, which is 32, which is going to give you 4 √2, or the square root of 32 for the hypotenuse. So therefore, our sine of theta, since we're in the second quadrant, sine will be positive. Sine is opposite over hypotenuse, so √7 over 4 √2. And you can leave it like that. You can rationalize if you want to. Multiply top and bottom by √2 would give you a √14 over 8. Either one is fine. So now how do I find the cosine of 2 theta? We're going to do 1 minus 2 times the sine of theta squared. Well, the sine of theta was √14 over 8 squared. Sine of theta squared. So let's go ahead and clean that up. That'll be 1 minus 2 times 14 over 64. And that will cross cancel and reduce. Let's go ahead and reduce it first. That's going to be 7 over 32. Let's now cross cancel. The 2 and 32 gives me a 1 and 16. So that's 1 minus 7 over 16, which is 9/16. Okay, next up, half angles. And again, what a half angle would do, if you know the cosine of 45, it tells you the cosine of 22.5. Let's look at our note here. It says, note to determine the sine, determine the quadrant in which the half angle lies. So now we have to kind of understand what we're doing because, look, there's a plus and minus here. So we've got to say, okay, if we're given the sine of 120 and we want to find the sine of half that angle, do we use a positive or negative? It all depends on what quadrant you're in. So you can look there, the sine of an angle divided by 2 is equal to this. The cosine of an angle divided by 2 is equal to this. And then there's 3 different ones for the tangent. So what we're going to do is we're going to first off, what is the cosine of 67.5? Now what we've got to first do is get that to fit our formula. So what I'm going to do, if you were to double 67.5, it gives you 135. So I'm going to rewrite this as the cosine of 135 divided by 2, which again is 67.5. Why did I do that? So that it looks like this. So what's in the place of my theta? 135. So I'm going to do is equal to plus and minus, and I'm going to simply plug it into my formula. The square root of 1 plus the cosine of theta. Now again, what was theta right here? It was the 135. So 1 plus the cosine of 135 over 2. Now again, which one do I pick, the plus or the minus? Look where you're at. You're finding the cosine of 67.5. 67.5 is up here in the first quadrant. The cosine in the first quadrant, as well as everything, is positive. So therefore, you're going to use the plus sign. So now you just clean it up. Is equal to the positive square root of 1 plus. Now, in order to find this, we've got to find the cosine of 135. Now, that 135 is over here in the second quadrant, though, where cosine is negative. So the cosine of 135 is going to be negative. Use its reference angle, which is 45, and that's going to be negative root 2 over 2. So there you go. So the cosine 135, negative root 2 over 2. And again, the plus minus bothers me. Let's just put the 1 minus sign, positive, negative, combines to become a negative. Now let's clean this up. 1 minus root 2 over 2, we need a common denominator, which is going to be 2. So I changed my 1 to 2 over 2. Let's subtract those two values. So I now have on top of this fraction bar 2 minus root 2 over 2. And then that whole thing is also over 2. So what do I do now? Inside of this fraction, I flip and multiply. So I now have the square root. When you flip and multiply, you're going to do times 1/2. That's going to be 2 minus root 2 all over 4. And that can be simplified by splitting the square root and doing the square root of the top over the square of the bottom. The square root of 4 is 2. So there's your exact value. Now, I do want to remind you, you could have actually taken your calculator and typed the cosine of 67.5 into your calculator. However, what we just did is we found an exact value of it. Now, why are we doing this? We're doing this simply for extra practice. We're learning or we're practicing our algebra skills, as well as we are incorporating these identities to get us a little bit of extra practice recognizing and using these identities. Okay, number 5, the tangent of 157.5. Let's first off double it and write that as the tangent of, that'd be 315 degrees over 2. Double 157.5, it gives you 315. So these two values are the same thing. Now, why did we do it? We did it to fit this formula. The tangent of an angle over 2, or the tangent of a half angle, is equal to. Now, you can use any of these three different ones. The first one, however, notice only involves cosines. You don't have to find the cosine and the sine values as you do with the other one. So let's go ahead and use the first one. So let's copy it down. Now, one thing that is different about this, though, it still involves the plus minus, which is really easy to figure out which one to use. But if you look at the other ones, notice that you don't have to worry about the plus minus with either one of those. But we'll do it this way just to give us a little bit of extra practice, because all we have to do is we're looking for the tangent of 157.5. 157.5 is somewhere over here where all students take calculus. S means that sine is positive, so therefore tangent will be negative, because the only thing is positive sine. So you've taken care of that. So what we need is we need the cosine of our angle theta. Now, what is theta? If you look at my formula, theta is the value on top, so the theta is 315. So to get this to work, we've got to figure out what is the cosine of 315. Well, to figure that out, all students take calculus. 315 is going to be down here in the fourth quadrant. All students take calculus. Cosine will be positive. Our reference angle is a 45 degree, so the cosine of 45 is root 2 over 2. So everywhere you have the cosine of 315, we're simply going to replace it with root 2 over 2. So 315 over 2, we've got the negative square root of 1 minus root 2 over 2 over 1 plus root 2 over 2. Common denominators, I'm just going to erase this 1 and write it as 2 over 2 and do the exact same thing on bottom. So let's clean that up. So we have the negative square root. On top you have 2 minus root 2 over 2. And on bottom you have 2 plus the square root of 2 over 2. When you flip and multiply, since you have a 2 on both of these fractions on the bottom, they're going to cancel each other out anyway. So we now have the negative square root, and this is the hard part, is just cleaning this one up. 2 minus root 2 over 2 plus root 2. You might think, okay, can I stop there? Well, let's get rid of that radical on bottom. You have a binomial that has a radical in it. Let's get rid of that. And the way you do that inside of these fraction bars, let's multiply top and bottom by that conjugate. So we now have the square root. On top, you have 2 minus root 2 times 2 minus root 2. That must be FOILed. 2 times 2 is 4. And I'm going to do a shortcut here. I'm going to multiply these two and these two at the same time. And you'll get a negative 2 root 2 and another negative 2 root 2, which will be a negative 4 root 2. And then finally, negative root 2 and negative root 2 will be a positive 2. On bottom, to multiply conjugates, you're going to do 2 times 2 is 4. And then positive root 2 times negative root 2 will be a negative 2. So we've nearly got it cleaned up now. So on top, you have the negative square root. 4 and 2 gives you 6 minus 4 root 2, all over 4 minus 2, which is 2. So let's come over here and write our final answer over here. Divide each of those by 2. That's going to be the negative square root. 6 divided by 2 is 3. Minus 4 root 2 divided by 2 would be 2 root 2. Now you do have to be careful, because had you worked this out the other way, let me share this with you. Had you worked this out the other way, it would have gave you a different answer. It would have gave you 1 minus square root of 2. And you're like, well, that's two completely different answers. However, if you were to type both of these in and get decimal approximations, you find out they're actually the exact same answer. So just because your answer doesn't look exactly like the way theirs does not mean it's not the correct answer. So go ahead and type it in, find decimal approximations to see, is my answer the same thing as their answer. Okay, number 6. You look for the sine of 11 pi over 12. And again, I like to change this to a degree measure. So 11 pi over 12, that's going to be pi over 12 would be 15. 11 15s would be 165 degrees. And honestly, you don't even need a double angle. You know the sine of, the sine of 165. However, let's do it the way they want us to. Let's rewrite this as double the 165. It gives you 330. So let's write it as 330 over 2. Now we need a formula for the sine of alpha over 2, or the sine of theta over 2. They use theta in theirs. Sine of theta over 2 is equal to, let's find it right here. Plus and minus the square root of 1 minus cosine theta over 2. Let's write that formula down. Now in our problem, our theta matches up with the 330. So pretty much all you have to do here is take out the theta. Now we still have our plus minus. We'll take care of in just a second. Take out the theta, put in 330 degrees, and clean it up. Now you are finding the sine of 165 is what you're actually doing here. 165 is a second quadrant angle, somewhere right in here. All students take calculus. So therefore sine, which is what we're looking for, sine will be positive. So therefore our answer is going to be the positive square root. The next thing we need is, in our formula, we have to find the cosine of 330. All students take calculus. 330 is somewhere down here, so therefore cosine will be positive. Our reference angle for 330 is 30. That's how far it is from the x-axis. So therefore the cosine of 330 is equal to positive. Use the reference angle. The cosine of 30 is root 3 over 2. So in my formula, I have 1 minus root 3 over 2 over 2. Common denominator on top. Let's go ahead and change colors here. That'll be a 2 over 2. So I now have the square root of 2 minus root 3 all over 2, and then all that over 2. In order to get rid of this fraction, I'm going to flip and multiply. That's going to be the square root of 2 minus root 3 all over 4. And I can split that square root and split it into the square root of the top over the square root of 4, which is 2. Okay, the next one. Number 7, a little bit different. They don't tell you on up here, they've been telling you the angles. What is the sine of this angle? What is the cosine of this angle? They gave you the angle. Here they don't. They say the cosine of some angle is equal to negative 3/8. Find the sine of half of that angle. The way that we're going to find the sine of half that angle, pretty easy. First off, let's write down our formula. Now, here's the tricky part, though. Am I going to use the positive or am I going to use the negative? I'm looking for the sine of theta over 2. Now, be careful here. This is the angle. This is the original angle. The original angle is between, let me write it like this, is somewhere between 90 and 180, correct? I'm looking for the sine of half of that angle. So if I were to take half of this angle, I'm going to be somewhere between 45, which is half of 90, and 90, which is half of 180. So my original angle is between 90 and 180. Half of the angle is going to be somewhere between 45 and 90. So therefore, this angle, this half angle, is going to be somewhere in the first quadrant. Now, how do I know that? Because the angles between 45 and 90 is in the first quadrant. So I'm looking for the sine of an angle that's in the first quadrant. All students take calculus. So therefore, this answer will be positive. The sine of my half angle will be positive. So now what do? I just plug in the cosine of theta and I'm done. So therefore, the square root of 1 minus the cosine of theta, which they actually gave to me, negative 3/8. Now, sometimes they're not going to give it to you. Sometimes they might give you tangent or sine, and you have to find the cosine by using those same measurements as what we've been doing. Minus minus makes a plus. Common denominator, 8 over 8 plus 3 over 8 on bottom gives you an 11, or on top gives you an 11 over 8. Flip and multiply, that's going to be the square root of 11 over 16. Split that, that's going to be root 11 over the square root of 16, which gives you 4. Next one. We're looking for the tangent. They give us all this information. We're looking for the tangent of theta over 2. Let's start with our formula. The tangent of theta over 2 is equal to, and we know we have 3 different ones. Well, since we're given sine, let's do the one that involves sine. Well, we have an issue there, though. If we look at our formulas here, here's our 3 formulas. The ones that involve sines also involve cosines as well. So you can use those if you want to, or I'm going to do this just to make you have extra practice with that whole plus minus. I'm going to use that first formula. So let's go ahead and copy it down. And there you go. Now let's talk about, is my answer going to be a positive or negative? Here it tells me that my angle, my theta, is somewhere between 270 and 360. So let's write it down like this. My angle is somewhere between 270 and 360 degrees. However, I'm looking for the tangent of half of that angle. If I half that angle, half 270 and half 360, that tells me that the half angle will be somewhere between 135 and 180. Now think about where that's located. 135 to 180. 135 is about right here. 180 is about right here. So there's between 135 and 180. That's the second quadrant. So I'm looking for the tangent of an angle, of a half angle that's in the second quadrant. All students take calculus. Tangent is negative. So to take care of that sign to begin with, I'm going to make sure I work with the negative. Now, look at your formula. I need a cosine theta and a cosine theta to plug in. I have a sine theta. The way that we've been working this, okay, forget about our formula for a second. The sine of theta, which is told us right here, was between 270 and 360. Our angle is. We're somewhere down here. All students take calculus. Notice how sine was negative. The reason why is because we're in the fourth quadrant. That's where theta is located. So how do I find the cosine, which is what I need for my formula? I draw myself a little right triangle. Here's my theta. And again, I'm dealing with theta here, not theta over 2. I know that sine is opposite over hypotenuse. And I know that's a triple. That's a 5, 12, 13 right triangle. Or you can use the Pythagorean theorem. Now, reminder, you can also, just if you want to, you can also use your identities. Sine squared plus cosine squared is equal to 1. If you're given sine and you need cosine, that's another method of working. And that, to me, it takes a little bit longer. I like this method. It's a little bit quicker. So we need cosine for our formula. The cosine of theta, since we're in the fourth quadrant, cosine is positive. Since we need cosine, that's adjacent over hypotenuse, which is 5/13. This would have gave you the exact same answer. So now back to our formula. Our formula says that the tangent of theta over 2, which is what we're looking to, is equal to negative square root of 1 minus the cosine of theta over 1 plus the cosine of theta. Common denominators is going to be 13. So this is going to be 13 over 13 minus 5 over 13, which gives you 8 over 13. This will be 13 over 13 plus 5 over 13, which gives you 18 over 13. When you flip and multiply, the 13s cancel and leaves you with the negative square root of 8 over 18. Now we can reduce that. That's the negative square root of 4/9. And that's an easy one to find the square root of. Find the square root of the top, and the square root of the bottom gives you negative 2/3. So therefore, what did we just do? Because a lot of times we get lost with this. We were given the sine of some angle. We have no idea what the angle is. Now we could find it by doing inverse sine. We were given the sine of some angle. We wanted to find the tangent of half of whatever that angle is. Now, do we even know the angle? Still don't. Have no clue what the angle is. However, the tangent of half of this angle is going to equal negative 2/3. Number 9. We're given a tangent, and we're given that we're somewhere between 180 and 270. Our theta is. Theta is somewhere between 180 and 270. So therefore, theta over 2 will be somewhere between 90 and 135. Now, what quadrant is that? Let's see, our theta, let me do it in a different color. 180 and 270, our theta, our original angle is in quadrant 3. Our half angle is between 90 and 135, which is in quadrant 2. That's going to be important to us. And we're looking for the cosine of theta over 2. So let's go ahead and write our formula from our reference sheet. And there it is. Now the cosine of my theta over 2. Okay, theta over 2 is in our second quadrant. Let me sketch that. Somewhere over here, all students take calculus, so therefore cosine will be negative. That's all we needed that for. Since we're in the second quadrant, cosine's negative, we're done with all this. So there's my formula. I'm given, let's see, I'm given tangent is 4√3. So let's sketch a little triangle. Let's first find out if it's positive or negative. Our theta is in quadrant 3. So let's just draw me an angle down here. All students take calculus. Notice that tangent was positive. It's because we're in quadrant 3. However, what about our cosine, which is what I'm going to be looking for? Since we're in quadrant 3, all students take calculus. Our cosine value will be negative. And that's all we needed that for. Now let's sketch out a little triangle. I know the tangent of my angle is 4√3 over 1. So opposite is 4√3, and adjacent would be 1. Pythagorean theorem, you've got to do a squared. Now I got to square this. To square a 4√3, square the 4, square the root 3. That'll be a 16 times 3, which is 48, plus b squared is equal to c squared. Work that out, and you find out that your missing side, your hypotenuse, is 7. So therefore, cosine, which is adjacent over hypotenuse, will be negative 1/7. That goes into your formula. Now we're ready to clean up our formula. The cosine of theta over 2 will equal the negative square root of 1 plus the cosine. Here's the cosine. That's 1 plus negative 1/7, which would be 1 minus 1/7 over 2. Clean it up, common denominator on top. That's going to be 7 over 7 minus 1 over 7, which is 6 over 7 over 2. Flip and multiply, so we're going to do times 1/2. That's going to be the negative square root of, let's cross cancel, that's a 1 and a 3. So that's going to give you 3/7. Let's write that as the negative square root of 3 over the square root of 7 and rationalize by multiplying top and bottom by root 7. That's going to be negative root 21 over 7 will be the cosine of theta over 2.